Thanks for reviewing my session on elegant async patterns and functional programming techniques you can use for scaling your multi-core JavaScript. This session is targeted at intermediate to advanced JavaScript developers on both the front end and back end. We cover 3 techniques you can use on your Node.js server and web app. JavaScript is highly concurrent by default thanks to the event loop, yet shields us from multithreading woes and synchronization primitives prominent in other languages. For example, each of these API calls seamlessly fires up a separate thread for a total of 4 threads, the main orchestrator thread plus 3 others. But usually we tell JavaScript what should run concurrently with promise.all. But in non-trivial apps, this fights against the grain of JavaScript. What if we treated threads and async tasks like dependencies and modeled a dependency graph for the runtime to evaluate? To accomplish this, we'll begin the session with async immediately invoked function expressions, an elegant pattern for managing concurrency from a single thread. The Async IIFE allows us to group together sequential code into a single unit called a task. A task can depend on other tasks too, as a source of input and produces one output. And with multiple tasks, we can leverage local variables and concurrency by default and essentially create a dependency graph, which the JavaScript runtime will optimally evaluate for us no matter how complex. You can read this blog post to learn more about the Async IIFE pattern. Second, we'll cover functional programming patterns for managing concurrency. We could use semaphores to limit concurrent access to a shared resource, like a database or network I/O, but this approach introduces brittle boilerplate. Instead, we can use function composition to decorate an existing function with throttling behavior. And finally, we create our own long-lived tasks with a web worker cluster, yet consume them like native async APIs with an approach that resembles Elixir's actor model and Go channels. We can expose remote procedure calls to the worker when it needs to synchronize with the main thread, and then with async iteration plus SharedArrayBuffers, we can write elegant web workers for the browser and Node too with the popular thread polyfill. Node and front-end developers alike are commonly trolled by the classic question, how do you scale a JavaScript codebase since it's single-threaded? While many developers turn to Node's cluster module or PM2, turning to multiprocessing too soon negates many single-process benefits. But a single JavaScript runtime thread can orchestrate an admirable amount of work. And luckily, these design patterns will help developers scale their codebases elegantly. And recipes and patterns outlive libraries, so this session emphasizes concepts over framework-specific solutions. Because unlike third-party libraries, patterns rooted in JavaScript and good software design will survive fads and never be subjected to breaking changes. As a full-stack consultant and instructor, I create ambitious web apps and Node backends for my clients and then distill the techniques for my students. I'm a co-author of a full-stack web development guide and international speaker at conferences across the US, Europe, and South America, so I can't wait to be part of your conference. Thank you so much for considering my talk.